I'm Aaron Fawn, and I'm on a trip for life in the Motor City.
I believe our future depends powerfully on how well we understand this cosmos, in which we float like a mote of dust in the morning sky.
Good morning, everyone. I'm here in Detroit at the North American International Auto Show to see if there's anything interesting and new that might carry us forth into a better future. These are hard economic times, so it's time for the car companies to step up to the plate and produce something interesting. We'll see whether that's true or not. It certainly hasn't been in the past. So let's go inside and see. The major manufacturers' booths at the auto show are certainly impressive. It's not that surprising. They have all sorts of money to spend on spokespeople, lighting, and set design, with which to wow your eyes and please your ears and empty your wallet. But are the major manufacturers really the place to look for the latest in energy-saving technology? In the past, they've promised much and delivered little. Well, let's look through the best of what they had on offer at the show, and then move on to some of the smaller manufacturers. The Volkswagen NCC reportedly gets 30 miles per gallon and looks much like a BMW. Speaking of BMW, the active hybrid X6 gets 26 miles per gallon. They were very proud of this, but it's disappointing. The Honda ZR-Z reportedly gets 38 miles per gallon, also disappointing given how small it is. The Honda Insight gets 41 miles per gallon and has already been released. The GMC Yukon Hybrid gets 22 miles per gallon, which is impressive given that it's huge. The Chevy Volt reportedly gets 50 miles per gallon. I guess we'll have to trust them on that. The Ford Fusion Hybrid gets 38 miles per gallon and is a Prius underneath. The Mercury Mariner is also a Prius underneath and also gets 38 miles per gallon. The Toyota Prius plug-in was on prominent display, but no mileage given. The Lexus 600 HL Hybrid gets 21 miles per gallon, unimpressive. The Lexus HS 250h gets 34 miles per gallon, which is better. The Hyundai Blue Wheel got a very impressive 50 to 100 miles per gallon, but no production plans. Omitting all the vehicles for which there are no immediate production plans, and averaging the mileage together produces a result of 33.8 miles per gallon in average fuel economy. Now, consider this for a moment. The 1929 Model A Ford got roughly 30 miles per gallon on average, which means in the last 80 years we've only progressed roughly 10% in mileage figures, and this is even counting things in the most charitable possible way, looking only at the latest in hybrid technology from all the latest manufacturers. What if airspeed had only progressed 10% in this period of time? The fastest plane of that age was the Orion L9 from Lockheed, which got 220 miles per hour. Imagine if this Lockheed plane got about 240 miles per hour as its top speed. Or let's look at it in terms of computers. The first computer got 5.8 megahertz. Let's say that you had a computer that ran 8 megahertz. Do you think you'd be watching The Trip for Life on that? However, if innovation is what you're looking for, the major manufacturers did have a lot of very innovative LED walls plastered all over their booths. I'm not sure how this improves the vehicles, but they seem to put a lot of effort into it this year. A number of major and minor manufacturers had electric vehicles on display, cordoned off in the electric avenue. Many of these are at varying levels of production readiness, and those that are ready, like the iMIV here, are really not that impressive. However, there were a number of entrants in the Automotive X Prize competition, and over the next year or so we will see whether or not these designs have any promise. Additionally, there was the Tesla White Star, which is their new sedan, and another vehicle that's already under production, the Commuter Cars Tango. I happened to get an interview with their representative. I'm here with Brian Woodbury, who is here to present the Tango electric vehicle, which is a two-seat electric vehicle. So what would you say is the key innovation of this electric vehicle in comparison to the others here?
It's a ballasted narrow vehicle. This is the only car in the world that doesn't get stuck in traffic jams.
I know a fair amount about this vehicle. If I were to say what the key innovation is, I would say it's actually the way that the batteries are positioned in the vehicle. Would you mind explaining a little bit about that?
Yeah, that's why I said it was a ballasted narrow vehicle. So it's ballasted like a sailboat for stability. So there are 2,000 pounds of batteries and motors 4 inches off the ground, and the carbon fiber body weighs 25 pounds. So the center of mass is actually under the floor. If you saw it without the body, it would look like a lead go-kart.
Excellent. So the batteries that this vehicle is using, are they lead-acid batteries?
This car has a temporary lead-acid pack, and all of our customers have ordered lithium-ion.
So when do you expect the lithium-ion batteries to be available?
Within a month or two.
So the main advantage that's caused by the ballasted vehicle design of the Tango is that it allows for the vehicle to corner at very high speeds. The lithium-ion battery pack will probably weigh a lot less, so is there going to be any sort of downside to the lithium-ion pack?
It weighs a couple 100 pounds less, so we'll add a sheet of lead underneath it.
And one final question. Some people might have some issues about the safety of a vehicle like this. What have you done to address the safety issues with such a narrow vehicle?
We have an FIA-certified chrome moly roll cage. It's rated for crashes at over 200 miles an hour, and NASCAR-style door bars, which are pinned into the cage. So it's actually 4 times more side protection than an SUV.
This interest in the Asian market is unsurprising given that there were 2 Chinese manufacturers at the show that I'd never heard of, both of which had electric vehicles on display. BYD also had some hybrids, and CT&T, which was focused upon their City EV electric vehicle in 2 models, represented here by a naughty schoolgirl and a dominatrix. They were pretty much the only booth babes at the show, and they were certainly the least tastefully dressed. Next, I made my way into the basement of the Kobo Center, where the Eco Experience was going on. This was a long concourse where you could drive ecologically friendly vehicles, if you didn't mind standing in line all day. Well, I didn't want to stand in line all day, so I just took some pictures, and looked at the ecological carnage they were creating to make a point. Yes, we're here at the North American International Auto Show, where ecology means planting daffodils inside, where they'll surely die. It's kind of sad. But is there really anything new at the auto show? They had electric vehicles like this all the way back in 1922. What we need is something truly new, an invention that can carry us in the future while using less energy doing it. Well, I found such an invention in the HP2G hybrid electric motor. This engine, invented by Doug Palmiere in Ohio, is making its debut in the Revenge Verde supercar. But with EPA-verified figures such as 400 horsepower and 500 foot-pounds of torque, while maintaining an outstanding 100-plus miles per gallon, I hope this engine has a bright future outside of the supercar segment. I managed to score an interview with Doug Palmiere about his new engine. What's the key difference, as you see it, between your hybrid engine technology and the technologies that are on offer from the other manufacturers?
I don't have to plug into the grid. It produces its own electricity. So I'd say that's a big difference. Incorporating it inside of an engine, making it the first true hybrid engine. 2 power sources in one.
Excellent. So, integrating electromagnets into the crankshaft seems like a rather radical change in the traditional internal combustion engine. What inspired this design change? I understand you've been driving around in a modified Mustang for quite some time that uses variations of this technology.
Well, true inspiration obviously comes from a higher authority. So I do believe in God, and I believe that I was put here to make this happen.
So, this design has some striking similarities to another revolutionary motor that has come out in the last few years. That is Kohei Minato's so-called magic electric motor, which is now in use in Japan and many places to drive air through supermarkets. It essentially uses a series of electromagnets on a rotor, which then interacts with permanent magnets that are mounted around the outside of the engine. I noticed in your design you have permanent magnets that rotate around and then the electromagnets pulse against them. Is that correct?
That's correct. So I reversed in electric motor technology.
Yeah, exactly. It's very interesting. Now, Chevy was supposed to have a half-finished Volt engine here. They were supposed to be showing off the battery pack and some other transmission components. I noticed upon going around here, they don't even have that on display. And yet, your engine, which has significantly more development behind it, it's already running, it's working, it's not on display here at the show. Why is that?
I can only assume that we're setting in Detroit, where the automakers are from.
So, this was more or less what I was assuming, was that they didn't want to be embarrassed on their home turf by an upstart.
You can guess. I don't know.
Now, have you gotten any interest from the major manufacturers in this technology?
Everybody here from the major OEMs have been here to talk to me.
So they have been talking with you. That's good news. So they're struggling with this efficiency problem too, and it looks like, to no small extent, the answers are coming from outside of the traditional industry. Given your interactions with the industry so far, how welcoming do you think that they've been to new technologies coming in from the outside to sort of jumpstart their own development?
I don't know if they're jump starting their technology or not. A lot of times they tend to buy the technologies up from the smaller guys and you've never heard of.
Indeed.
I held mine. I didn't sell it. Been offered quite a few times. I think it's, if a true inventor wants to see their product out on the market being used and not variations of it. So I had an idea where I wanted to go with it and how I wanted to put it out there, and I'm pursuing that idea.
Given how many technologies have been shelved due to internal corporate politics over the years, great technologies that had real potential, I think that was probably a wise decision on your part. You've said in the past that the advantage of this technology is it's ideal for retrofitting existing cars. I like this quite a bit because it means that there's a lot less energy investment in building whole new vehicles to house technologies that could just be basically grafted onto existing platforms. So are you going to offer this technology as sort of a crate engine so that people can upgrade their own vehicles?
Yes, and we're setting up centers to install it because the technology is new enough they won't understand how to do it. Your normal person that works on cars won't understand it because it's both mechanical and electrical, so there's more to it. I'm working with our local colleges there in Ohio, 3 of them right now. We're setting up training of that, so they're looking at the technology and teaching the kids.
And 2 more questions, and I'll let you go for the day. First off, all the retrofit technologies I've seen so far require the loss of a great deal of trunk space due to batteries and other electronic bits that need to be put somewhere. Compared to traditional hybrid technologies, how much space is taken up by batteries with your technology?
I only have 2 batteries, 2 12-volt batteries. Work on a 12-volt system. A normal hybrid runs as high as 650 volts.
So there's a lot less risk to rescue personnel if there's an auto accident.
Correct.
Excellent. And finally, how long do we have to wait before I can retrofit my Civic? I'd love to be able to get this in a 4-cylinder engine. Is there development taking place to put this into smaller engines? And do you anticipate that that would produce even higher efficiency than we're seeing in a V8?
I can't really say where it's going to be yet. I wouldn't just throw a number out there because I like to know first. But yes, we're working on smaller engines, and then also we're looking at larger engines because the bigger need is semis. Semis move about everything we have. So I do have semis out there running around with my technology already.
Excellent. There is semi trucks. That was the one thing I was wondering. Is the torque is actually high enough coming out of these engines that it could serve as a semi. So that's very significant. Thank you for telling me that. All right. Well, it's been very nice doing this interview with you. I'm glad I was able to run into you. Let's compare a typical internal combustion engine with Doug Palmier's new engine. In a typical 4-stroke, you have a piston, a connecting rod, and a crankshaft, and a lot of other stuff I'm omitting for the sake of simplicity. Let's get rid of the connecting rod and go through the cycles. First, gas and air are introduced, and they are compressed and combusted. Then power is produced, and finally exhaust is pushed out. One more time, gas and air are introduced, then they are compressed and combusted. Then there is the power cycle, and exhaust is pushed out. By comparison, Mr. Palmier's new engine has several new components: pulsed electromagnets both above the cylinders and around the crankshaft, and permanent magnets placed to take advantage of this pulsing. Now, I don't know whether it's being pulsed from positive to negative. That's a bit of a trade secret, I guess. But I'm guessing that this is the case. At any rate, these pulsations within the electromagnets have the effect of both increasing the compression within the cylinder and improving the torque characteristics of the engine. So, Doug, what can we do to actually see such engines on the market?
I think the biggest push for change is going to be the people that say they want new technologies. They won't buy the old technologies anymore, that they're going to actually say they want it.
So there you go. If we want it, we can have a better future. But we can't expect the major manufacturers to just give it to us. We're going to have to demand it.
The sky calls to us. If we do not destroy ourselves, we will one day venture to the stars.